Good morning, esteemed guests, deans, HODs, registrar, faculty, staff, members of the press, and officers from CBC and ISRO. We welcome you all to NIT Trichy as we gather for the interaction session with the youths of India under the Amrit Kal initiative.
We cannot express our enthusiasm for being given an opportunity to host the man behind one of our country's proudest achievements, Dr. P Veeramuthuvel, the project director for Chandrayan 3.
Before we hear from a distinguished guest, we would like to call upon the HOD of Production Engineering Department, Dr. Narayan, to deliver the welcome address.
Respected Director, Honorable Chief Guest, Deans, Registrar in Charge, HODs, Professors, Staff, Press and Media, members of CBC, Pragyan team, students, friends. Good morning to you all. Vanakkam. I am very happy and proud to welcome today's Chief Guest, Dr. P Veeramuthuvel, Project Director, Chandrayan 3. I am also very much delighted because he is from our production engineering department. On behalf of our institution, our production engineering department, I welcome you, sir. திட்டமிட்டு சந்திரனில் தென்துருவம் தொட்டுவிட்ட சந்திராயன் 3 திட்ட இயக்குனரே வருக. தொட்டுவிட்ட பொழுதிலும் வெற்றி கணம் நெற்றி தொடா வெற்றி வேலே வருக. நிலவின் நினைவில் நாம் நீந்த நிலவில் நீந்தும் சிறந்ததொரு நீச்சல் வீரரே வருக. திரு பழனிவேலு படைத்த பண்புமிக்க வீரமுத்துவேலே வருக. 15 நாட்களில் பர்த்டே கொண்டாடவிருக்கும் பகட்டில்லா நாயகனே வருக. அட்வான்ஸ் ஹாப்பி பர்த்டே சார். மற்றவர்க்கு கனவானவற்றை தன் கடின முயற்சியால் நினைவாக்குவார். திருமதி கவிதாவின் கணவரே வருக. திருப்தியை மகளாய் பெற்ற திறம்படைத்த தந்தையான வெற்றியாளரே வருக. ரயில் பள்ளியில் ஏறி 7 மடை அடைந்து பல்தொழில்நுட்பம் பயின்று தொழிலக பொறியியல் தேசிய தொழில்நுட்ப கல்லூரியில் பயின்ற பெருமகனே வருக. அகில புகழ் படைத்த NITTயில் அகிலா மேடம் தலைமை வைக்க ஆர்ப்பரிக்க கொண்டாடும் பிரக்யான் நிகழ்வில் பேச வந்த பெருமகனே வருக. ஒன்ஸ் அகைன் ஐ வெல்கம் யூ சார். வெல்கம். அடுத்து மூன்று துறைக்கு தலைமையேற்றிருந்து 3 நிறுவனம் செழிக்க பணிபுரிந்து 3 மிஷன் வெற்றியாளரை பிரக்யான் விழாவிற்கு அழைத்து வந்து கலைமகள் அலைமகள் மலைமகள் போல் வீற்றிருக்கும் இயக்குனர் அவர்களையும் வருக வருக என்று வரவேற்கிறேன். ஐ வெல்கம் யூ மேடம். I extend my warm welcome to the Deans, Registrar in Charge, HODs, Professors, Press and Media, members of CBC, staff members, and Pragyan team members, and students, friends, and everyone to this function. I once again welcome you all. Thank you.
Thank you, sir.
We now invite our respected director, Dr. G. Aguila, to deliver the presidential address.
Good morning, everyone, and I welcome you all. Special welcome to our chief guest and the alumni of NIT Trichy 2003 batch Industrial Engineering, MTech Industrial Engineering, Dr. Veeramuthuvel. I would like to recall only one moment. On the day of Chandrayan 3 mission landing, everyone we were gathered in our Bonn hall with all the students. The moment when it landed, it gave us the pride to each and everyone that it is our victory, that it is our mission, it got success. And that is the way how we saw your victory, sir. And thank you for that. And thank you for the entire team for making our India to be in this position at the world level. And coming to other parts, when I interacted with Dr. Veeramuthuvel, That was the first time I'm contacting him, such a humble person. And he told, yes, I want to come. Whenever I'm free, definitely I'll make it available. But you know, right now, even the PMO office, they wanted to felicitate them. But because of the work pressure, they did not go there to Delhi to receive it. But we got it or received it only through online. That was the information he gave. That is the kind of dedication and what is the work assigned to them, how they have to work. That is the lesson we have to learn from the whole team. Thank you for doing that. And day before yesterday, for the inauguration of our Festember 23, from Sriharikota, Sri Syed Hamid, he was there. When his speech or during his speech, he gave only one word: ISRO culture. ISRO culture. That is the ISRO culture. He used to use this word often. Then I asked him, what is the ISRO culture? Any guess? Any guess? Given the work, we have to complete it. We won't look into time, we won't look for food, anything. Given the work, we have to complete. That is the ISRO culture. Then that was the moment I thought each and every one of us, we should have a culture with us so that we can, whatever the leap we are taking ahead, we can reach up to that level. An example is sitting before us, and wholeheartedly on behalf of everyone, once again, a warm welcome. And you please share all your experience to our students here. And another set of students are also waiting in the other hall also, because this is restricted. If possible, we can meet those people. And the students, you please make use of this opportunity, and whatever you would like to have it in your life, whatever the aim or goal you have, please have some culture like what the ISRO culture tells. And here, we are not here to define your own culture. You have to define on its own. I am sure that the experiences of Dr. Veeramuthuvel, what he is going to share with us, it is going to kindle the thought in us. Thank you once again for coming, and I welcome you, sir. Thank you for the.
Thank you, ma'am. We call upon Professor Ashokan from the Production Engineering Department to present Dr. P. Veeramuthuvel with a bouquet.
We invite Akila ma'am to present Dr. P. Veeramuthuvel with an institute memento.
We call upon our Student Welfare Dean, Dr. Karvembu, to present Dr. P. Veeramuthuvel with a Pragyan memento.
With a notable list of achievements under his belt, our guest needs no introduction. A proud NITT alum, Dr. P. Veeramuthuvel joined ISRO in 2014, and nothing has looked the same ever since. He worked on various remote sensing and scientific satellites, including the Mars Orbiter mission. He also continued pursuing academic research parallelly and completed his post-graduation at IIT Madras.
Subsequently, he led ISRO's first nanosatellite team and launched 3 such satellites. Subsequently, he led ISRO's first nanosatellite team and launched 3 such satellites. He worked as the Associate Project Director for Chandrayan 2 and was later nominated as the Project Director for the monumental Chandrayan 3 mission. Chandrayan 3 also had the honor of being the forefront of India's Amritkal journey, roughly translating to the golden era. Amritkal envisions economic development and prosperity for India.
His journey to being one of the top scientists in India is awe-inspiring, to say the least. With a flair for breaking barriers and turning tides, here we have Dr. P Veeramuthuvel to impart his knowledge and expertise to our audience.
Good morning to all of you, respected Director NIT, Dean, Registrar, Professor Punyamurthy sir and Ashokan sir. They were my teaching gurus. I am just standing in front of them. I don't know how I will justify, but I will try to be a good student like how I was at that time. And all the distinguished invitees who are present here, and most importantly, dear students, greetings to all of you. And it's my thank you, Director, for inviting me to be part of this event. First of all, thanks to all of the faculties, production engineering faculties, those days who were teaching me. I remember Nurlak sir. I came to know that sir is not here today. And Ashokan sir had taught me genetic algorithm. I still remember the genetic algorithm. I have applied in my early part of my life. And also Punyamurthy sir, I can still remember the project management, how the project means, what is the difference between project and production engineering. And I still remember the fundamentals what he taught me. I remember, I carry forward. And we used to discuss a lot. In fact, in our batch, 4 of us joined in ISRO and 1 person left. 3 of us still in ISRO. So we used to discuss about the NIT college days and the fundamentals what we learned, especially from 3 gurus, I would say. Nurlak sir is not there. Punyamurthy sir and Ashokan sir is really, they are very good in fundamentals, and that fundamentals is very important because that only that never changes, like how Newton law did not change. So whatever we do, but the fundamentals will never change, and that is very important in our day-to-day life also. And I also very happy that it's like a homecoming for me. So after a long time I have come and no change. The campus is very beautiful only, and thanks for all the arrangements. I told madam 2 days before, madam, I am coming to Tiruchi. I would love to come here and make some presentation if you can accommodate. So immediately madam has arranged. By seeing the arrangements, I have no words to say, because in such a short time, the organizers, I thank organizers as well as all the people who are involved in this. It's such a great thing. I will not spend much time. Some few minutes I will talk about Chandrayan 3, because you would have heard through internet, you would have heard through interviews, like many people would have seen the literatures. There are many papers available, but still I will tell what we have done, and towards the end of it, whatever the questions you have, I am ready to answer. See, all of you are aware that landing onto the lunar surface is quite complex. There are 3 countries which had achieved this safe and soft landing onto the lunar surface. One is US, Russians, and then Chinese. US had many programs, like they had Ranger, Surveyor, and Apollo mission. Ranger and Surveyor, they had a robotic missions. No, it was not a crewed mission, whereas Apollo was a crewed mission. First, initially, they also had a failures, and then Surveyor has given a lot of confidence to US people, and subsequently they had a Apollo program, and followed by USSR also, not followed, in parallel with the US, they also had a Luna program. And then Chinese have started in 2008. They called Chang'e missions. So Chang'e 1 and 2 was an orbiting mission. Chang'e 3 was a landing mission. And of course, our India has got a Chandrayan program. Chandrayan 1, you all must be knowing. Chandrayan 1 had found water on the moon. That only created a lot of interest again going to moon. And Chandrayan 2, we had an objective, orbiting as well as landing, but landing we could not achieve. Finally, Chandrayan 3 program has come. And if you see the landing points, there are so many landing took place. All were near to the equator. We were the first one to go near to the South Pole. So our landing target, landing coordinate was 69.9 degree latitude towards south and 32.3 degree towards east. So that is the farthest point from the equator. So because why we have chosen this point is basically what for we are going, we have to do some science exploration, how this planetary systems have evolved, because studying from Earth has a limited knowledge, whereas Moon is undisturbed place where we can find out how this Milky Way galaxy has come. Like that's a lot of science questions are there which we can answer. Second is Moon also can be treated like a gateway to go to other planets, because Earth has got Earth. If you have to go from Earth to some other planet, the escaping velocity from the Earth is 11.2 kilometer per second. So you require large energy. Whereas Moon has got a very less escaping velocity. It is around 2.4 kilometer per second. So you can easily go to another planet, provided we get some resources like water. Water can be used as a rocket fuel. So you can set up a rocket station at Moon, like how we have our own Sriharikota. So these are all a futuristic plan. That's how this program has started. Then second is we can also have a human colonization. We do not know, after several years, we can also go as a space tourism. So such questions are there. That's how this program has come. And particularly South Pole has got a lot of resources like water particles. There are places where permanently shadowed region. In those places there are frozen water particles are there. That's the interest for us. I have some few slides at the end of it, what are the science outcome from this mission. I will explain in briefly. So having told about okay, till that comes, there are many unsuccessful attempts, even not only for India, even US has 3 unsuccessful attempts before the first successful attempt. Similar way for Russians also, before they actually successfully landed, they had 11 failures. And Chandrayan, India also has got 1 failure, that is Chandrayan 2, for not having a successful attempt. But nevertheless, at least second attempt we had a successful landing. And coming to a complexity wise, see, Moon mission, unlike other missions, like we have different applications in the satellite. One is remote sensing, then communication satellite, and navigation type of applications. But Moon also is quite complex because we cannot launch every time. This is what I was telling. Yeah, USSR has got 11 unsuccessful attempts, and other recent unsuccessful attempts also. Just before our Chandrayan 3, Luna 25 also had a crash landing, and before that Akuta R1, this is from Japanese, they also had a crash landing. Bearsheet from Israel, that also has a hard landing. So what it gives is the mission is very complex in nature. The reason is you are starting with the 0 meter per second velocity, you are attaining nearly 11 kilometer per second. Capturing the Moon itself is complex because there is Moon gravitational forces involved. You have to capture properly. Again, with the orbital velocity, you have to kill from nearly 1.68 kilometer per second to nearly 0 meter per second, and to a designated landing point. That's how the complexity is. And we want to go to the same point because of the terrain nature is there, where we cannot have a hazardous zone. We should see that obstacles are not there at the time of landing. So that's how the point becomes very important, and velocity also we have to kill. So this becomes more and more complex. This is one order complexity compared to any other satellite missions. So just to tell that why this complexity between Earth and Moon, many of you know the difference. One of the differences, the gravitational force is 1/6 of the gravitational force of Earth is Moon. So nearly 1.62 meter per second square is the gravitational force. And second important thing is the escaping velocity, which I told, 11.2 kilometer per second is the Earth escaping velocity, whereas Moon is 2.38 kilometer per second. And the temperature, unlike Earth is having an habitable planet because ours is surrounded by atmosphere. Even if it is a night or a day, our temperatures is on an average it is minus around 15 degrees centigrade, whereas Moon is not like that. When sun is there, it goes to 120 to 150 degrees centigrade. When sun is not there, it goes to minus 150 to minus 170 degrees centigrade, because there is no convective heat transfer there. Due to this reason, you have to have a craft which will survive for these conditions. That becomes another complexity. And the third one is the vacuum. There is no atmosphere. it is fully vacuum. That vacuum, under that radiation effect is there. That totally the solar radiation pressure comes and it attracts the satellite. So that is another problem. Then the fourth one is, unlike in Earth, we have 12 days, 12 hours of day and 12 hours of night. Whereas in Moon, it is, when sun is there, it is continuously available for one lunar day is equivalent to 14 Earth days. Similar way, one lunar night is equivalent to 14 Earth days. So our entire mission life is only one lunar day. That's how our design itself, because when sun is not there, it goes to minus 150 degrees centigrade, and nowhere the electronic packages like avionic packages, RF systems cannot survive for very low temperature. It is way beyond our storage temperatures. Even our mobiles, if you see, it will not work to minus 150 degrees centigrade. So our design itself is only one lunar day, and you know, the moon is away from Earth by 3.84 lakh kilometers. That is another challenge. You have to capture the moon with such a distance. So that's how the phase becomes more complex. First thing is, the launch phase itself is very complex. You have to, our expectation from the launch vehicle is, you have to inject the spacecraft with certain precision. That is the height of the satellite from the Earth's surface, then what is the velocity it requires, and what is the orbit required, then argument of perigee and inclination, so on. So many parameters are there. Unlike other spacecraft, we cannot have a launch opportunity every month or every 15 days. Here, twice in a year only that opportunity comes. That becomes another complexity. Then earthbound phase, we have our own limited capability. Launch vehicle does not have, like, beyond 4-ton mass it cannot carry. Our spacecraft mass is 4 ton, around 4000 kg. So we have to necessarily utilize our own launch vehicle, because it's a science mission. We have to reduce our budget also. So we have opted for our own rocket. So with this capability, we cannot directly go to moon. So we have our own propulsion system, which will increase the height. You would have seen in internet, this is how that orbit takes place. It will go around the Earth as soon as the launch vehicle injects the spacecraft. Then further, we have our own chemical propulsion system. We have one tiny rocket in the spacecraft which will raise the orbit. Finally, it will bring the orbit closer to the 4 lakh kilometer where the moon orbit is there. So finally, when we come to the moon's orbit, again we have to capture that velocity. We need to trim. We have to have a retrofiring, capture the moon, and go around the moon. Finally, again when we capture, it will be an elliptical in nature. You have to circularize. That's how that orbit design is. So it's very complex, the design of the orbit, because even at the time or a date or underperformance or overperformance, we may miss the moon, because moon is coming. It is coming to that particular position, particular orientation, and we need to capture that particular time and particular orientation. That becomes very crucial. That's why we call it as even 10 seconds delay will cause a bigger, we may miss the moon also. When we depart from the Earth, that is called translunar injection. If you miss by 10 seconds, you will miss the moon. Similar way, when we go to the moon, if you don't retrofire, you may miss the moon again, you will come back to Earth. So such a complexity it involves. So the date and time becomes more important. Then, having told all these things, the most critical part is landing. The landing is, just because there is no atmosphere, you cannot use parachute. Like, for example, if you are because Earth has got an atmosphere, if you want to increase the drag, you can use parachute, by which you can kill the velocity. Since there is vacuum in moon, you have to use active chemical propulsion system, which means you have to kill the velocity only by that. So we have to necessarily have our own propulsion system. That is again complex. And another important thing is, no ground intervention during that 19 minutes. We call it as a 19 minutes terror. You are descending from 30 kilometer with such a velocity, 1.68 kilometer per second. You just imagine 1.68 kilometer per second, one object is traveling, and you have to kill the velocity and you have to come to the same point. So that means all the systems present in the lander, that is navigation, guidance, control, sensors, propulsion system, everything should work in unison. And whatever we design for, it should deliver in that particular 19 minutes. So all the real-time decisions it has to take on its own, no ground intervention, because time is very short. And second is, it has to avoid the obstacles. Like, we do not know, whatever we characterize, we do not know whether we will have a soft landing or not. So during that, just before landing, we built the necessary intelligence, like artificial intelligence, machine learning, like that. We have built in so many other things also, so that it will avoid the obstacles. You would have seen during the descent time, we had several phases like rough braking phase, attitude hold phase, and then fine braking phase. We killed fully the velocity and we are just over the landing site. We were taking pictures because in moon there is no GPS. So GPS means you will know that x, y, z, that is position, x dot, y dot, z dot, velocity. So all the 6 state vectors is available to you in ground. So you can fix the GPS in the car and you can track. Whereas in moon that provision is not there. So we have to necessarily use some sensors which will give altitude information, which will give velocity information. In addition to that, it will give some hazard avoidance information. So we have operated certain cameras during the hovering phase. You would have seen during the visuals like the spacecraft is hovering at 800-meter point as well as at 150-meter point. So that was designed to just operate the sensors and update the inertial sensors. So in space, or in other words, all other spacecraft, we use inertial sensors. Inertial sensors means it will give delta V and delta theta information, because that is what is in closed loop. So anything, if I have to go from one place to another place, I should know that where I am. Then only I will know that where I have to go. So similar way, the guidance requires navigation information. That information is provided by inertial sensor. Again, the inertial sensor, over time it gets corrupted. We need to update with the absolute sensors, that is called terrain relative navigation sensor. So these are all the first time developed instruments. It has a full of new technologies, it is full of innovation. So those systems needs to be characterized. So after characterization, this has to work, it has to deliver in that 19 minutes. That becomes more important. Then another one important thing is the dust also plays a major role. At the time of landing, we should not have a dust fear. So for that, we have created certain systems like to overcome the dust also. And having told all these things, the most important point is, how do we get the confidence? We know that, okay, we have designed the system, but it has to deliver. Moon has got a distinct differences with respect to Earth, which I already told. So how do we characterize? So you have to create the moon environment at Earth, and we have to thoroughly do the testing. That becomes vital. Whatever I said, sensors characterization, be it sensor characterization, be it propulsion system characterization, be it guidance or control, everything needs to be characterized, for which we designed 3 important tests: simulating the atmospheric effect, accounting the atmospheric effect, compensating the gravity, and again the another thing is 1/6 of gravity. So how do we have to have a necessarily a scaled down model of lander, and also it should give a kind of environment where it is not which is not hazardous, because we are using chemical propulsion system. It should not be harmful to the people. So all such things we have to take care. We devised hundreds of tests. One is we did in Chitradurga, where we flew all the sensors and navigation system in helicopter, and we created artificial lunar craters and boulders, and we tested thoroughly for about 25 hours of flying time at various altitudes, at various velocities, which was done. Second test is, having done the sensors and navigation, we have put propulsion system also in closed loop, and we created another test in in Sriharikota, where we hired a tower crane and we tested thoroughly all other systems like propulsion system. Then the third important test is, we created lunar soil simulant test bed. So NIT has supported greatly for this test, where we took a anorthosite rock from near to Salem, and it has a near similar chemical properties of lunar surface, and we pulverized into samples, soil samples, and we created a test bed, and we dropped the lander physically, not one test, series of tests with the different touchstone combinations, because at the time of touchstone, it's not only vertical velocity, it can come with the horizontal velocity, and terrain condition we do not know whether it is a flat or it is a slopey terrain, and we do not know whether boulders or craters are there. So with all the combinations we tested in that bed. So that is the third important test we did. This gave enormous confidence. And you all know that Chandrayan 2 also, you supposed to know that Chandrayan 2, everything went well except for the landing. We again had a beautiful flight in the month of July 2019, and all these earthbound maneuvers, lunar-bound maneuvers, everything took place properly. And we also have a orbiter and lander which got separated. Finally, when it comes to descent phase, you can see the red color curve is the expected trajectory, and the dotted blue one is the what has happened during that time. You can see here the first phase, the rough braking phase, went well. The next phase, the deviation started, where the red color You can see the deviation started from the attitude hold phase, camera coasting phase, and at the end of attitude hold phase, it is way beyond our state vectors, which is we design anything we design for some dispersion parameters. If it is beyond the dispersion parameters, no system will work. So on that day we had 24 sigma kind of a dispersion, which is way beyond, and our capability is with the lesser energy we have to go to the same landing point. You assume you have less energy, like you have a car with certain velocity capability, and you have to reach to the destination with that velocity. It is impossible to reach. Similar way, the lander also had lesser energy, but you have to go to the same landing site point. So what happened, it asked for an aggressive maneuver. In that process we lost altitude, we gained velocity. At the time of touchdown, our residual velocity was nearly 50 meter per second in both the directions. See, our lander legs also, even our own legs is capable to jump for some jumping I can take, but I cannot jump from 10th floor. So no way our legs will survive. Similar way only lander also has got a lug which has capability to withstand some 2 meter per second horizontal direction, as well as some 0.5 meter per second in vertical, horizontal direction 0.5, vertical direction 2 meter per second. But it is 50 meter per second, which is way beyond the capability of the lander leg. So it had a crash landing. This is how the scenario of Chandrayan 2. So one thing is we have learned from the Chandrayan 2. That was the first experience we have utilized. So Chandrayan 2 heritage is utilized to a greater extent for Chandrayan 3 configuration. Then on orbit we have addressed, like learning from the mistake. See, we know that what was a failure. We thoroughly had a failure analysis committee wherein we pinpointed what went wrong and what are the corrective actions required. Then third important thing is our ISRO mentality, I would say. Anything you ask for repeating the mission, we will never repeat, we will improvise. We will see that how to improve in every system. Likewise in lander, every system got improved and we made it more robust. Then fourth important point is, as I told, ground test. Whatever the lacuna was there during Chandrayan 2 ground test, so we had a brainstorming session in the beginning itself. What are the tests we have to do which gives confidence, which will have a near equivalent moon environment? That is the fourth point. Then the fifth point is, before the actual 19 minutes which I was talking, how do we characterize in the on orbit? Like we are in the space for 40 days after the launch. How do we characterize each and every system so that before that 19 minutes descent, we have more confidence? So this is where our aim was. These 5 elements led to safe and soft landing. That is how our configuration arrived. Then so many things which I am not going into detail during the question and answer session. Based on your burn, I can dwell more on it. But lot of improvements we have done. One of the simple improvement is we built so many multiple mission parts in that 19 minutes. Anything happening, like one propulsion system, one engine not working, one sensor not working, and one system is going off, all the failure handling capability we foresee, and we built the failure handling capability in that 19 minutes. All the necessary intelligence is built so that we will not have a surprise. We wanted a soft landing. That was our target. Then second point is full level redundancies. Redundancies in the sense, like for example, one example I would say, it has to give one height information. We had 2 height sensor. One is RF based principle, that is microwave based principle. Another one is laser based principle. So we had 2 sensors. If one is not working, another one should take care. So any system, no system was having without any redundancy. So that one more thing we built. Then 3 tests which I already talked about. On orbit testing also I have already talked about. And you would have seen again, we had a LVM-3 rocket. We used LVM-3 rocket. That is the highest capability rocket ISRO has got, which will deliver 4000 kg of satellite into a geosynchronous orbit. So that's how we utilized. Our mass is 3896 kg. The entire Chandrayan 3 mass is 3896 kg, which injected into an orbit of 170 by 36,500 kilometer. Plus minus 500 kilometer was the expectation from the launch vehicle. So we got exactly within the tolerance. So that was a first achievement for us. Second is, as I told, earthbound maneuvers and all. Then we had 3 modules in this Chandrayan 3 itself. One is lander module, propulsion module, rover. Propulsion module job is to take the lander and deliver the lander at the moon's orbit. That was his job. Lander module job is to have a landing. And after landing, rover has to come out from the lander. It has a mobility function. It should travel from one point to another point, and it has to conduct in situ scientific experiments. And the right side picture you can see, that is how the Chandrayan 3 looks. It is integrated module. The bottom one is a propulsion module. The bottom one is a propulsion module, and top is a lander, and rover is accommodated inside. And we have 5 scientific instruments, 3 in lander, 2 in rover, which has got, even though the mass and size is less, but it is all developed with the state of art instrument. And our main objective is safe and soft landing, rover roving on a moon surface and conducting in situ scientific experiment for 1 lunar day. That was our mission objective. And this is a mission profile. I will not dwell. This all we got exactly like we had. For every burn we had a contingency plan. If plan A is not working, what is a plan B? But still everything went plan A only. There was no problem at all. We were very fortunate in that way. And finally this descent phase, it is also similar like Chandrayan 2, but with lot of robustness. Like as I told, 3 sigma is one dispersion parameter. Every parameter is almost 176 parameters. It can vary on the day, can go wrong. So what we designed this time is, assume that 176 parameters are going wrong, but still we want to land. That is called additive extreme simulations we do. Everything taking into positive sense and everything taking into negative sense. But generally no, if you see, if you are a statistical person, we do a normal distribution, and we do a Monte Carlo simulation. But this time we did an additive extreme simulation, everything going wrong like that. So that much of robustness we built, and ensure that we still have a soft landing. And finally the landing site coordinates, this is very important, 69.3 degrees south and 32.3 degree east. That was the primary landing site target. And if 23rd August, if that was not happening, we had an alternate landing site which comes on the west side. After several orbits, automatically, because it's an inertial orbit, the orbit will come to the west side, and 26th August we would have descended. For that also we had a plan B. And for our fortunate, we had a textbook landing, and we were off by 300 meters from the targeted point. Just to give a photograph of these pictures, like this is how the final spacecraft looks like: propulsion module, rover and lander, and integrated module. These were the test, the 3 important tests which I was referring. One is inside the helicopter, then this is an outdoor test where the engines has to be fired and we have to do a hovering and all. The third test is what I was telling. This is a lunar soil simulant test bed, where we had a flat terrain and a slopey terrain. We dropped multiple landers, created 1/6 of mass, because gravity we cannot reduce in earth. We can only simulate, we can reduce by 1/6 of mass. That's how we did. And just to, you can click one video, some 5 minutes video is there, just in the same folder. The same folder, you can click that video.
The Chandrayan 3 spacecraft consists of a propulsion module and a lander module, with a rover accommodated inside the lander. The propulsion module and the lander module are stacked together to form the integrated module. 6 modules were realized during Chandrayan 3 project life cycle, out of which 3 were flight modules and 3 were special test modules, namely the integrated cold test, integrated hot test, and lander leg drop test modules.
The main function of propulsion module is to carry the lander module from launch vehicle injection till lander separation. The propulsion module was made ready for further integration with lander module.
A 6-wheeled rover is accommodated inside the lander, which would be deployed onto the lunar surface post-landing. rover solar panel deployment and illumination test, rover standalone EMI-EMC test, vibration test, thermovacuum test, and mass property measurements were carried out. All tests associated to rover were successfully completed and the rover was made ready for further integration onto lander. After integration, detailed IST, sensor level alignment and EMI-EMC tests were also carried out before shipment to ASTE Bangalore. A new facility was realized at SDSE Shar for conducting the IHT, craters and boulders simulating hazards during landing. A total of 20 tests were successfully conducted, which include 6 dry runs, 8 static tests, and 6 dynamic closed-loop tests. The lander leg drop tests were carried out to evaluate the energy absorption capability, strength and stability aspects of lander legs during touchdown. A new facility was realized at iSite with a test bed with flat and 12-degree inclined drop surface. Detailed tests were carried out at damper level, single leg level, simulator level, and QM structure level for various touchdown velocities on flat and sloped surface and on lunar soil simulant and hard surface. A total of 15 drop tests at simulator level and 2 drop tests at QM structure level were conducted successfully. The objective of lander is to demonstrate safe and soft landing on lunar surface. Major elements of lander include sensors, after the completion of thermal elements in the rover compartment, the rover was assembled onto the ramp using 3 hold-downs. Detailed assembled mode IST was carried out, followed by mass property measurement, thermovacuum test, solar panel assembly and illumination tests, EMI-EMC test at CATF iSite. This was followed by pre-dynamic deployment of secondary rover ramp, primary ramp and rover rollout from lander and payload deployments such as ILSA and Ramba, chased, and the lander was made ready for further activities. Once the lander module was ready, it was stacked over the propulsion module to form the integrated module. EMI-EMC, vibration tests, acoustic tests were carried out. Final finishing activities such as MLI sealing, Chandrayan 3 spacecraft was made ready for shipment to spaceport at SDSE Shar.
This video you have seen just before the shipment to Shar, because we generally after the spacecraft is ready at Bangalore, we will transport by road, and rocket also comes to from Trivandrum to Sriharikota by road. We get integrated at the launch pad and the launch takes place at Sriharikota. After the spacecraft is shifted, we have to fill the fuel, because this fuel we have basically the bipropellant propulsion system. We have the fuel of hydrogen and MON3 as oxidizer. This has to be filled in both propulsion module and lander, and then once this spacecraft is ready, it will be encapsulated. You are seeing the right side picture. There are 2 heat shield which gets assembled, and again it is transported to the launch pad. And you know, this you would have seen in TV, the launch pad. After that, after moving it to the launch pad, within 7 days we will have a launch. And after the launch, this all we already covered. We have several earthborne maneuvers and translunar injection, lunar orbit insertion, and finally the lander propulsion module has separated the lander, and within 6 days we have to land. And you would have seen during the landing time, we have put one camera for public outreach. That camera's job is from 30 km till landing, portion of lander and portion of lunar surface it has to capture. So you can see every 3 seconds, you know, from the moon to earth, it is less than a second, we will get the telemetry as well as commanding also. This image, because it's a large data, it comes every 3 seconds. In that 19 minutes, every 3 seconds, we have visuals coming from the spacecraft to ground station, which is located at Bangalore. And the most important and interesting point is the Chandrayan 2, even though the landing has failed, but it has got an orbiting operation. The orbiter was actually designed for 1 year. It's now more than 4 years, still it is going great. And this we have one orbiter high resolution camera, which is having 0.32 meter resolution, which is the best available globally. Even US lunar reconnaissance orbiter, all those are having 0.5 meter resolution. This is the best resolution we had. Before the Chandrayan 3 launch itself, we characterize our landing site. Another important point is the landing site of Chandrayan 3 is 4 km by 2.4 km, whereas in Chandrayan 2 it was 0.5 by 0.5 km, because Chandrayan 2 time the orbiter has to take the image. Before the landing it has to transfer to lander, and there are some limited storage memory. So all those things we overcome in Chandrayan 3. A priori to launch, we have characterized that landing site using the orbiter high resolution camera in Chandrayan 2. We have loaded in that digital processing unit, which is used at 150 meter. When the camera is taking a picture, it will compare with respect to the onboard stored image, and there is an image processing technique involved, and it will avoid the obstacle. That's how that entire plan was. So this camera, after the landing, the left side picture is before the landing, which is taken by orbiter high resolution camera of Chandrayan 2. And this is after the landing. You can see the lander was captured by orbiter high resolution camera. And this is something you can see the visuals. This is how the animation is. You have landed. After the landing, you are deploying the ramp, and there is a primary ramp deployment, and upon which a rover comes on and solar panel gets deployed. It establishes the communication between rover and lander, because rover cannot communicate directly with the earth. It is always communicate via lander. And this is the actual onboard visuals coming from the moon. Lander has got one camera which captured the ramp deployment and rover mobility, and the rover has come out from the ramp and it entered into the lunar surface. This captured by lander camera, actual onboard visual. And this is very interesting picture on the left side. See, always our team used to refer before the landing. 3 countries were successfully landed, our US, Russians and Chinese. We used to refer the publications, how their lander was upright landing onto the surface. So when we saw that when rover moved away by 30 meters, rover has got its own camera. We call it as a navigation camera for path planning. That camera has captured the lander. And by seeing this lander now, we got really a goosebump that lander is upright. And not only that, the lander is upright, and we had a deployable scientific instruments. One actually got inserted into the lunar regolith. Second one is the ILSA payload, where it measures the seismic activity. So that also has to be dropped onto the surface. All those things also captured. So it is like seeing is believing, even though telemetry is available, but that also was captured. Then the right side picture you can see, when the rover coming out of the ramp, you know, in the South Pole, it's not like the sun will come on top of our head, on the top of our lander, in other words. But because of the pole, the sun actually have an elevation angle of 0 degree to 22 degree, and again 22 degree to 0 degree. In that process, the azimuth also is there. It travels from east and it goes to north and it settles at west. So during that time, because of the lower elevation angle, even a small height of the object, it casts a long shadow, and it's a moving shadow. So when you see here, when we landed, we had 3 body mounted solar panel, so that it generates power, because we were purely depending on solar power generation. We don't have any nuclear resources. So the sun comes on the east side, we have one panel. It moves to north side, we had another panel, and it comes to west side, we have another panel. During this process, Whenever it hits the east side, it casts a shadow onto the west. Similar way, when it comes to north, it has a shadow on south, and west means east shadow will be there. During this time, half of the portion, 2 meters, it will travel to come out of the lander. There is a ramp which has a distance of 2 meters before it touches the surface. During this process, there was a casting shadow, and we saw this, our ISRO, our Indian flag was put on rear side of the rover. So we could capture that Indian flag, and back side of the wheel we had one national emblem, and then our ISRO logo, that also was captured. These are the things, because the wheel has got a circular in nature. We have put an emblem, very innovatively we have put an emblem which is glued with several pieces, that also was captured. And this is what I was referring, the payloads. This is an INSA payload which is dropped onto the surface, and there is a probe, you can see here. This probe is penetrated inside the regolith. That also was captured. And another one payload is called surface plasma environment studies. That also is a deployable payload. It has to study the plasmas. So that also was captured. And finally, our Prime Minister has kept the point as Shiv Shakti point, where lander has landed. From the lander landed, the rover has traveled like this, in this path. We have put a boundary within this our rover capability. We have moved the rover by nearly 101.4 meter. We have moved within 9 days, within 9 to 10 days. It's a very great achievement, because even the Changi missions and all, 6 months they operated, they moved by 120 meters. So almost 24/7 we have operated. Rover, unlike lander, rover has got a semi-autonomous way of handling. No autonomous is built. So it has to take a picture. It's like how our eyes are there. It has 2 navigation camera. It will take a picture, and it has to avoid the obstacle, and we have to plan the path from point A to point B, and it has to download through lander. After that, we have to, after moving, we have to operate the scientific instrument, again download the data. Like that, it goes on for 24/7 in that 9-10 days. So we moved by 101.4 meter. We collected several scientific instruments. This is the third objective. We had our scientific scope is, first we have to land, and no one has landed in that particular zone. And there our idea is elemental composition. It has to identify the major rock forming elements, minor rock forming elements, like various elements are there, we know. And it has to conduct surface plasma environment, because it has got a great importance, and this is first of its kind, in situ measurement. Third one is accelerometer or seismic activity. That is also a very important thing, because it can come from natural way, it can come from artificial way. You know, there are so many meteoroids are impacting onto the moon surface. Because of that, the craters are formed. So what is that kind of events also we want to capture. The fourth one is thermophysical properties, like the variation of temperature across the depth and the thermal conductivity. So there are various elements. It has detected first time sulfur, along with major other things like aluminum, calcium, iron, manganese, magnesium, oxide. So many elements it has captured. This is the first cut data. There are many analyses going on. We will have so many publications shortly. And then the second one is, as I told, it's a near surface plasma environment. This is again a first time. Here we have operated and it has found a lot of electron density and electron temperature varying the sun intensity. This is again a first time instrument. In fact, no one has conducted this type of experiment. And the third one is, as I told, eye accelerometer was there, eye sensitive accelerometer was there. That also captured the rover movement as well as natural events. And then fourth one is the temperature measurements. Like as I told, 100 mm it is inserted into the regolith, and over that 100 mm it detected the temperature variation and as well as thermal conductivity. And this is the finally, before our end of mission, we have conducted one hop-on experiment, which you would have seen. We took off from the place where we landed, and this is the visuals coming. You can see some dust is coming in the center of the picture. So when we fire the engine, it creates lot of dust, and we just took off and then landed. This is something again a phenomenal, because we had lot of hesitations whether we will conduct this experiment properly or not. It has got lot of terrain resistance and all. So our management has given lot of confidence, and we conducted. And this picture also before the hop on. The left side picture is before the hop on, and right side picture is after the hop on, where it is landed. And again, we stowed back all the elements, like chaste got retracted, ILSA got retracted, ramp got closed. Again, after the hop on, we deployed back. we got one more day for our fortunate, and we operated the payload with a new location. So this acts like our precursor for our sample return mission, as well as it will act like a new location we have got. See, lander cannot move, lander is static in nature, but we moved the lander also one step. So with this, lot of informations are available in the website. If you have more doubts, you can refer. So with this, I will ask students to ask whatever the questions you have. I'm happy to answer. Yes. Facing it. No problem.
இப்போ என் டவுட் என்னதுன்னா, இந்த டஸ்ட்டுலாம் இருக்குல்ல சார் மூணில், மங்கள்யான் அப்போவே வந்து ஸ்பேஸ் டஸ்ட் வந்து ஒரு பெரிய இஷ்யூவாக இருக்கும் அப்படின்லாம் சொல்லி ரொம்ப இது கவலைப்பட்டிருந்தோம். இப்போ இதில் இவ்வளோ மூவிங் பார்ட்ஸ், இவ்வளோ ஓப்பனிங் க்ளோசிங் ஆக்டிவிட்டீஸ் இருக்கும்போது அந்த டஸ்ட்டு வந்து அந்த ரோவர் இருக்கிற ஒரு இடம் அங்கே எம்டியாக தானே சார் இருக்கும். அந்த வழியாக உள்ளே போய் இன்ஸ்ட்ருமெண்ட்ஸை டேம்பர் பண்ணாமல் எப்படி மெயின்டைன் பண்ணீங்க? எந்த ஒரு ஓப்பன் ஸ்பேஸும் இல்லாமல், எந்த ஒரு அந்த 3 hours ஃபுல்லாக டஸ்ட் இப்படி மேலே பறக்கிறப்போ அது அந்த சோலார் பேனல்ஸ் ஃபுல்லாக கவர் பண்ணி அந்த எனர்ஜி சப்ளையை பிளாக் பண்ணாத மாதிரி அது என்னென்ன ரிடண்டன்சிஸ் கொடுத்தீங்க சார் அதுக்கு?
உட்காருங்க. ஃபர்ஸ்ட் ஆஃப் ஆல் வந்து ஜாயின் பண்ணுங்க இஸ்ரோக்கு. இது இந்த மிஷனோட ஒன் ஆஃப் த அப்ஜெக்டிவ் வந்து நிறைய சயின்டிஃபிக் டெம்பர் க்ரியேட் பண்ணுறதுக்கு அது க்ரியேட் ஆகிருக்கு. ரெண்டாவது உங்கள் பாயிண்ட்டுக்கு வந்து இந்த லேண்டர் வந்து ரோவர் மூவ் ஆகும்போது நிறைய ஸ்பேஸ் இருக்குன்னு கேட்டிங்க. ஆக்சுவலாக இந்த ரோவரில் பார்த்தீங்கன்னா 6 வீல் இருக்குது. அந்த 6 வீலும் வந்து வீல் டிரைவ் மெக்கானிசம், இண்டிபெண்ட் வீல் டிரைவ் மெக்கானிசம். இது என்ன ஆகும்னா, இந்த பியரிங்லாம் பார்த்தீங்கன்னா, அந்த பியரிங்கில் வந்து ஒரு டஸ்ட்டு போயிருக்குன்னா இட் வில் கிரியேட் அ ஃப்ரிக்ஷன். அதுக்கு வந்து இட் இஸ் சீல்டு பியரிங். அது உள்ள டஸ்ட்டு போகாத அளவுக்கு நம்ம சீல் பண்ணியிருக்கோம். ரெண்டாவது, நம்ம லேண்ட் ஆனதுக்கப்புறம் சோலார் பவரை வச்சு தான் நம்ம பவர் ஜென்ரேஷனே இருக்குது. அதுக்கு வந்து 25% எக்ஸ்ட்ரா மார்ஜின் வச்சுருந்தோம். இந்த டஸ்ட்டுக்காக அக்கௌண்ட் பண்ணியிருந்தோம். இப்போ நீங்கள் பேனல் வந்து சைஸ் பண்ணும்போதே பார்த்தீங்கன்னா ஒரு சைஸ் இருக்கும். 1 square meterன்னு ஒரு எக்ஸாம்பிள் எடுத்துக்கலாம். 1 square meterக்கு வந்து பவர் ஜென்ரேட் பண்ணால் நமக்கு வந்து உள்ளுக்குள்ளே இருக்க சிஸ்டம்ஸ் எல்லாமே அதோட பவர் ரெக்குவயர்மெண்ட்டை மீட் பண்ணணும். நம்ம என்ன பண்ணோம்னா 1.25 square meterக்கு பேனல் வந்து டிசைன் பண்ணிடணும். மூணாவது கொஸ்டின் நீங்கள் கேட்டது, இந்த டஸ்ட்டு அவாய்ட் பண்ணுறதுக்கு கீழே பார்த்தீங்கன்னு வைங்க, லேண்டர் கீழே ஒரு தெர்மல் ப்ரொடெக்ஷன் சிஸ்டம்னு இருக்கும். அந்த தெர்மல் ப்ரொடெக்ஷன் சிஸ்டம் இஸ் ஃபுல்லி சீல்டு. நீங்கள் கீழே லேண்ட் ஆகும்போது கூட மேலே வந்து டஸ்ட் வரப்போகிறதில்ல, கீழே தான் வந்து டஸ்ட் வரும் எப்பயுமே. அதை வந்து நம்ம கவர் பண்ணிடணும். நாலாவது பாயிண்ட் வந்து நம்ம டஸ்ட்டு வந்து இட்ஸ் அ மேஜர் கன்சர்ன் தான். நம்ம லேண்ட் ஆகும்போது நம்ம எதிர்பார்த்த அளவுக்கு டஸ்ட்டே இல்லை. இப்போ ஃபார் எக்ஸாம்பிள் 19 ampere பவர் ஜென்ரேட் பண்ணணும்னா 19 ampere பவர் ஜென்ரேட் ஆச்சு. அதுக்கு என்ன பண்ணியிருந்தோம்னா, உடனே நம்ம ரேம்பை ஓப்பன் பண்ணல, ரோவரை வெளியில் எடுக்கல. கொஞ்ச நேரம் டஸ்ட்டு செட்டில் ஆகிறதுக்காக கொஞ்சம் டைம் கொடுத்துருந்தோம். 3 hours கிட்ட டைம் கொடுத்துருந்தோம். உங்களுக்கு லேண்டிங்க்கு அப்புறம் விஷுவல்ஸ்லாம் இல்லை. நாங்கள் ஆல்மோஸ்ட் நைட் ஃபுல்லாக ஒர்க் பண்ணோம் அந்த ரோவர் ரேம்பை ஓப்பன் பண்ணுறதுக்கு, ரோவர் வந்து டிப்ளாய் பண்ணி ரோவரை ஆன் பண்ணி வெளியில் ரோல் அவுட் பண்ணுறதுக்குலாம் நமக்கு ஆல்மோஸ்ட் ஒரு நைட் ஃபுல்லாக போச்சு. அன்றைக்கி நைட் ஃபுல்லாக நம்ம ஒர்க் பண்ணோம். அப்புறம் பேலோடையும் டிப்ளாய் பண்ணோம். ஸோ டஸ்ட்டு செட்டில் ஆகிற வரையில் நம்ம வெயிட் பண்ணோம். இதெல்லாம் தான் நம்ம ஹேண்டில் பண்ணியிருக்கோம். அதே என்விரான்மெண்ட் மார்ஸ்க்கும் இருக்குன்னு அவசியம் கிடையாது. இது மூணோட என்விரான்மெண்ட். மார்ஸில் வந்து டஸ்ட் ஸ்டார்ம்லாம் இருக்குது. அது ரியலி அ கன்சர்ன். அதுக்கு வந்து நம்ம வந்து வி ஹவ் டு கம் அப் வித் இன்னோவேட்டிவ் லைக் டஸ்ட் கிளீனிங் மெக்கானிசம், அந்த மாதிரிலாம் நம்ம பண்ண வேண்டியிருக்கு. இதுக்கு வந்து நம்ம மார்ஜினை வச்சே நம்ம மேனேஜ் பண்ணியிருக்கோம்.
சார், இன்னொரு டவுட் என்னதுன்னா, இப்போ ஸ்பேஸ் எக்ஸ் ராக்கெட்லாம் வந்து ரீயூஸ் ஆகி கீழே லேண்ட் ஆகுதுல்ல, அப்போது அது வர வழி எல்லாமே வந்து எப்படி சொல்கிறது, பிளாக் கலர் கோக்கிங் ஆகுது அந்த இது கெரோசின் ஃபியூவல்னால. இப்போ அதே மாதிரி நம்ம விக்ரம் லேண்டர் வந்து மூணில் லேண்ட் ஆனப்போ அந்த மூன் டஸ்ட்டு அந்த ப்ரொபல்ஷன் அந்த கீழே அந்த பெல் நாசில்லையும் போய் ஒட்டிக்கலாம்ல. இப்போ ஹாப் டெஸ்ட் பண்ணும்போது அது மேலேயே ஃப்ளேம் போட்டுச்சுன்னா அது ஆக்சிடைஸ் ஆகி அது அந்த இன்ஜின் சைடெலாம் கரோட் பண்ணலாம். ஸோ அதுக்கு எப்படிப்பட்ட ப்ரொடெக்ஷன்லாம் கொடுத்தீங்க சார்?
இல்லை, இன்ஜினுக்கு தேவையே இல்லை. ஏன்னா இன்ஜின் வந்து உங்களுக்கு தெரியும், இட் ஹஸ் காட் அ வேக்யூம் ரிலேட்டட் த்ரஸ்ட், ப்ரெஷர் ரிலேட்டட் த்ரஸ்ட். அது ஹை வெலாசிட்டியில் வந்து கம்பஷன் ப்ராடக்ட்ஸை வந்து வெளியில் அனுப்புது. ஸோ நோ வே த
அதுவே
அதுவே வெளியில் அனுப்பிச்சிடும். உங்களுக்கு டஸ்ட் வர்றதுக்கு அதுதான் டஸ்ட்டு கிரியேட் பண்ணுது. அது டஸ்ட் வந்து அதை அட்ராக்ட் பண்ணுறதுக்கு வாய்ப்பே இல்லை. ஏன்னா அதுக்கு பயங்கர வெலாசிட்டியில் வந்து
செட்டில்
ஆகும்போது கூட வாய்ப்பே இல்லை. ஏன்னா உங்களுக்கு வந்து நீங்கள் ஃபயர் பண்ணுறீங்க இன்ஜினை டில் த எண்ட் ஆஃப் டச் டவுன். அங்கே ஒரு டச் டவுன் சென்சார் இருக்கும். லேண்டர் லெக்கில் ஃபார்த்தஸ்ட் லோயஸ்ட் பொசிஷனில் அந்த ஃபுட் பேட்னு சொல்லுவோம், அது கீழே ஒரு டச் டவுன் சென்சார் போட்டிருக்கோம். அதையும் வந்து கவர் பண்ணியிருப்போம், டஸ்ட் கவர் பண்ணியிருப்போம். ஸோ ஒன்ஸ் வந்து நம்ம இம்பேக்ட் ஆச்சுன்னா அதை பேஸ் பண்ணி இன்ஜினை ஆஃப் பண்ணுவோம். வித்தின் ஸ்மால் மைக்ரோ செகண்ட் வி ஹவ் டு டூ தட். அப்போ தான் இன்ஜின் ஆஃப் பண்ணதுக்கப்புறம் டஸ்ட் எல்லாமே செட்டில் ஆகிருக்கும். ஸோ இன்ஜினில் அந்த மாதிரி ஒரு ப்ராப்ளம் இல்லை நமக்கு. அது நம்ம ஸ்டடி பண்ணோம். இன்ஜின் கேனாட் ஹேவ் தட் கைண்ட் ஆஃப் ப்ராப்ளம்.
சரி சார், உங்க கூட பேச ரொம்ப பெருமையாக இருக்குது எனக்கு.
தேங்க்யூ.
Sir, hi sir, I'm Janardhan. First of all, congratulations for you. Congratulations for your success, and thank you for making us proud as a NIT student. And actually, India sent so many satellites into space, and with low cost actually compared to other countries. But why India didn't send any human till now into space?
See, please sit. So first of all, this human mission, first we have to take a first step for a soft landing. Soft landing itself is a technology. At least India is the 4th country to have now. We mastered that. Next only human exploration is possible. But Gaganyaan program. We have a Gaganyaan program coming up. That is a human exploration only. So the missions are on. It will take some time to. We have that roadmap, and we will have a launch very shortly. I mean, shortly means I should not be telling when is the launch. Higher management should tell. I will talk about only Chandrayan 3. But we have the program, Gaganyaan program, which will answer to your question.
A small another question, sir. When we are going to step on moon, like after 5 years or 10 years?
No, first step we have taken. We have to now have some more missions. See, this was a short-term mission. We have to have a long-term survivability also, for which we need to have a nuclear resources. Like, because lunar night, we are not able to survive. Lunar night, as I told, it is a very low temperature, way beyond our storage limits. So we have to warm the systems during the lunar night. Irrespective of the surface temperature reaching minus 150, the lander systems we have to keep it warmer. Like how during the winter we protect with the jacket. So even with the thermal protection system, we cannot protect it, attain thermal equilibrium. But inside we have to have some nuclear resources which will keep warmer. So that technology is required. We are in the process of doing that. Next step is only we have to go for human exploration. I cannot tell the timeline, but definitely ISRO is a very result oriented organization. With everyone works with the passion. I am sure that we will come up with the plans which I cannot tell now, but we are working on that.
Thank you, sir.
Hello, sir. I'm Shoykot from Tripoli 4th year. My question is, many private players are coming into the space technology like SpaceX, and many Indian states are also coming into the in this region. So my question is, what's your view on big privatization of this space technology? As many well-known people in space technology are against it, like Neil Armstrong. He was against it. Like, what's your view on it?
No, last point I didn't get. Neil Armstrong, whether he has landed or not is
no. He was against the privatization of space technology. So what's your view?
No, the recent space reforms announced by our Honorable Prime Minister, it's a good move, because see, now SpaceX, how it has come, because NASA, their way of dealing is, the government organization should mainly focus on research and development. The production part, like for example remote sensing, communication satellites, it's no more a new technology does not require. So you have to offsource to the private players, so that the market can be enhanced. Similar way we also adopted. Now under the new space reforms, there are many startups have come. Skyroot rockets, it has launched its own rocket, and there are many startups. Like I wanted to tell you, you should become an entrepreneur. You should be more of a job creator than job seeker. That should be. When I was studying at that time, we didn't have that kind of provision. Now we have that provision. You should not be joining only looking for some job. There are opportunities available. You can start your own industry, space industry, or you can actually you can tie up with ISRO, because this is very important. You have seen in the visuals a thermovacuum test, vibration test. This is one of its kind. What is the fundamental difference between our computers and spacecraft is the environment in which it undergoes. During launch, no, it attracts a lot of vibration. Similar way in space, whenever in the space, no, when sun is there, it will go to very high temperature, when sun is not there, very low temperature. So we have to simulate the vacuum environment, we have to simulate the extreme temperature and see that the systems are working. So such facilities you cannot create, for which ISRO is providing the facility. You can develop, you have to be very innovative, that's more important. If you have ideas, if you are very intelligent, there are many people in the market to realize the system. Even you can actually get the work done, build a satellite. All the test facility we are offering, ISRO is offering under the new space reforms, so that it eases your job. And launch also we have in PSLV, GSLV and Mark 3. There are opportunities. If you develop 10 kg satellite, you will get a slot for a launch. So that way you can utilize. It's a good move, no? I feel it is a good move.
Thank you, sir.
Good morning, sir. Myself Venugopal. I am pursuing Masters in Computer Science. 986 you are one of the main reasons, sir.
Thank you.
So, another question was ISRO, as you said that we are facing an issue with the escape velocity and all the fuel things, and I came that DRDO is currently testing on the hypersonic technology, which China has already did it, and they are having missiles. So, is there any scope that we could combine these technologies together so that we could reach even more faster to more planets within a shorter span? Can we do it?
No, please sit. DRDO, see, whatever we are seeing is with certain height. For example, 170 by 36,000 kilometer, which I was referring, all are under the atmosphere only, the velocity in which. But we require, first of all, we have a payload capability. I was telling 4000 kg satellite, you have to inject into a geosynchronous orbit and with a certain speed. That we have this much capability only. Now only, in fact, we cannot compare with the DRDO. That is a different, that's a different thing compared to whatever space we are talking about. But here itself, we are improving. Like next step is we are going for semi-cryo engines, where our payload mass can be enhanced. See, right now itself, if you see PSLV mass to GSLV mass, we have come all the way from 1000 kg to, in fact, earlier we started with 40 kg, now we have come to 4000 kg of geosynchronous. LEO orbit is 9000 kg. We are having plans. Another few years later, we will increase this mass. We wanted to make it thrice or four times. So plans are there. We are working on it.
Sure, sir. It's just an idea which came up with my mind whether we could combine this technology. Yeah.
Thank you.
Thank you, sir.
Hello, sir. My name is Parikshit from second year chemical engineering. So recently, after the successful mission of Chandrayan 3, one of the Chinese scientists made some comments about it. So any answer or what are your thoughts on these comments?
No. Yeah. See, I will tell you, it is not something we are telling now. Last 10 years, we are telling our latitude is 70-degree latitude, near to 70-degree latitude. US, European Space Agency, NASA, everyone is aware about it. You can also browse our landing site. 2013 we have decided, and that's how the engineering itself is made. There are 3 sites solar panel which I was referring. All these things are made vertically because sun orientation. Even top we have not put any solar panel. Everyone is aware. I don't know why this person is not aware. Second is, but we agree with him on one aspect is, east and we have always told near to South Pole. We never told we have landed on South Pole. In fact, in my speech also you see everyone's speech we have told near to South Pole only. So 70 degree latitude is near to South Pole. His definition is South Pole means 88.5 degree to 90 degree is the range he is telling. We agree with that. We don't have any dispute on that because Earth tilt angle is 23.5 degree. Whereas moon tilt angle is very less. Because of that, the south pole range is very small. Whereas here we can talk about 70 degree, 66 to be precise, 67.5 degree to 90 degree, we call it as south pole in Earth. Whereas there it is 88.5 degree to 90 degree, which we agree. And we never told we landed on South Pole. No, we always told near to South Pole only. And for this site, for this target, we only first time we went. Nobody else has gone.
Yes, sir. Thank you, sir.
Hi, sir. I have a small question. So, a lot of missions that we have undertaken, we have completed it successfully in the very first time. And every time we have been trying something new, we have been innovating, and it becomes a success. My question is, what principles are being undertaken at ISRO to make sure that all the innovations that we do get succeeded every single time in the very first attempt? So, how do you ensure that things go right?
No, first thing is, the very important thing is one is the team, and whatever the system we have in ISRO, it's a teamwork. Even though I am actually representing the team. It's not that my individual work, it's not my PhD, it's a teamwork. The team should be having the full knowledge, and everybody, whoever is there in every subsystem, we have the actual the specialist on that each area. Second is the review system. I have seen the ISRO review system is very transparent and open. For example, one person, who is joining now, can ask a question to chairman as well as to a project director, and he is supposed to answer that question. If I am a designer, I have to defend that. In all the reviews, there are several reviews right from the project inception till the launch. We have stage reviews. Every stage review, I should be getting the clearance, and it's transparent. Like all of you can come and ask questions. That transparency is one thing. And project planning, initially itself you have to plan properly. That what are the tests you have to do. That's why the brainstorming session we do. That is in the beginning itself. What was my challenge was, even though there are many experts available, the system engineering plays a major important role, and project management also. We have to be well within the time, we have to be well within the budget, we cannot compromise the quality, and we have to achieve the mission objective. This is my goal, and there are so many people are there to work, but how to plan it properly, how to conduct the test properly, conceptualize properly, and how to coordinate properly. There are within ISRO and outside ISRO. It's a big teamwork. These are all the challenging I feel, but every person will go through this, and the system is there. ISRO system is very good. That's how I feel.
As students, we also tend to do some projects during our course and after the course. So, what suggestions and advice would you like to give for us to have a success like ISRO?
So one is, if I take the journey of Chandrayan 3 itself, see, it's okay to fail, but attempting is more important. We should make an attempt, otherwise there is no use. And calculated risk is, we have to take. In everyday life, we have to take a calculated risk, and learning from the mistake. So for example, Chandrayan 3 team has done only with one focus, learn from the mistake and do 100% involved, with 100% involvement, with put your full hard work. Hard work is really required for the success. This is what I strongly believe in.
Thank you, sir.
Sir, hello sir. I am Sudarshanaram, Instrumentation and Control Engineering first year sir. Sir, எனக்கு ஒரு சின்ன டவுட் சார். நீங்கள் வந்து இப்போ ஒரு ப்ராஜெக்ட் மேனேஜராக இருக்கும்போது நீங்கள் நிறையா டீம்ஸை ஹேண்டில் பண்ணுற மாதிரி இருக்கும். இப்போது ரீசன்ட் ஜென்ரேஷனில் எங்களுக்கு வந்து நாங்கள் சின்ன டெஸ்ட் எழுதும் போதே நாங்கள் ரொம்ப ப்ரெஷரைஸ்ட் ஆகிக்கிறோம். நீங்கள் அவ்வளோ பெரிய டீம் வந்து நீங்கள் இது பண்ணும்போது நீங்கள் எப்படி ஹேண்டில் பண்ணீங்க? உங்கள் ப்ரெஷரை வந்து எப்படி ஹேண்டில் பண்ணீங்க? ஏன்னா நீங்கள் நேஷனோட ஒரு ட்ரீம்ஸை வந்து பின்னாடி நீங்கள் சுமந்துட்டு போகும்போது எப்படி நீங்கள் வந்து அதை ஹேண்டில் பண்ணீங்க? அஸ் அ டீம் ஹவ் யூ டிட் எனக்கு வந்து தெரிஞ்சாகணும்.
இல்லை, ஃபஸ்ட்டு வாட்டி எனக்கு வந்து பயம் இருந்துச்சு. உட்காருங்க ப்ளீஸ். ஃபஸ்ட்டு இந்த ப்ராஜெக்ட் டைரக்டராக கொடுக்கும்போது ஒரு மிக்ஸ்டு ஃபீலிங் தான், ஒரு மிக்ஸ்டு எமோஷன் தான் எனக்கும் இருந்துச்சு, எப்படி நம்ம ஹேண்டில் பண்ண போகிறோன்னு. ஆனால் ஒரு என்ன டிரைவிங்காக இருந்துச்சுன்னா, ஒரு வாட்டி நம்ம ஆல்ரெடி ஃபெயில் ஆகிருக்கோம். இந்த வாட்டி ஒரு ஃபோக்கஸ் என்னென்னா அதை லேண்ட் பண்ணணும். அதுதான் ரொம்ப இம்பார்ட்டண்ட்டாக இருந்துச்சு. ஸோ அதுதான் ரொம்ப டிசைர் ரொம்ப ஸ்ட்ராங்காக இருந்துச்சு. அதுக்கு என்னென்ன வேணுமோ அந்த டீம் ஃபுல்லாமே அதை மட்டும்தான் பண்ணணும். ஃபார் எக்ஸாம்பிள், டிஃப்ரென்ஸ் ஆஃப் ஒப்பீனியன் நிறைய வரும் டீமுக்குள்ளே. ஒருத்தவங்க வந்து இதுதான் பெஸ்ட்டுன்னுவாங்க, இன்னொருத்தவங்க இதுதான் பெஸ்ட்டுன்னுவாங்க. அது அப்படி தான் இருக்கும். ஆனால் ஃபைனலாக கோல் என்னென்னா, ஒரே ஒரு கோல் தான், சாஃப்ட் லேண்டிங். அதுக்கு என்ன தேவை? பெஸ்ட்டு. இண்டிவிஜுவலோட சிஸ்டம் அந்த கோல் தான் டாமினேட் பண்ணணும், நாட் இண்டிவிஜுவல் ஷுட் நாட் டாமினேட். ஸோ அதுதான் எங்களுக்குள்ள மைண்டு ஃபுல்லாக இருந்துச்சு. அப்புறம் ஹேண்டில் பண்ணும்போது இந்த ஸ்ட்ரெஸ் ஹேண்டில் பண்ணுறது கேட்டிங்க, அது சேலஞ்ச் தான், எவ்ரிடே சேலஞ்ச். ஆனால் உங்களுக்கு பேஷன் இருந்துச்சுன்னா, இதை பண்ணணுன்ற ஒரு பேஷன் இருந்துச்சுன்னா, என்ன மாதிரி இருந்தாலும் எண்ட் ஆஃப் த டே யூ வில் பி இப்போ நீங்கள் ரொம்ப ஒரு டேயில் ரொம்ப ஜாயஸாக இருக்கீங்க, அந்த டே வந்து ரொம்ப ஃபாஸ்ட்டாக போகும். இன்னொரு டே ரொம்ப ஸ்ட்ரெஸ்ஃபுல்லாக இருக்கீங்க, ஏதோ ஒரு பெரிய லாங்காக போகிற மாதிரி இருக்கும். எவ்ரிடே வந்து நீங்கள் அந்த ஒர்க் மேலே ஒரு பயங்கர ஒரு இன்ட்ரெஸ்டோட ஒரு பேஷனோட பண்ணிங்கன்னா யூ வில் நெவர் கெட் டயர்டு. அது ஒன்று. அது இல்லாமல் இப்போ நம்ம நிறைய ஸ்ட்ரெஸ் ரிலீவ் பண்ணுறதுக்கு காமெடி சேனல்ஸ் பார்க்குறோம், மூவி போகிறோம், ரெஸ்டாரண்ட் போகிறோம், டெம்பிள் போகிறோம். அந்த மாதிரி வி ஆல்சோ ஹேவ் அவர் ஓன் லைஃப். அப்படி தான் நம்ம ஸ்ட்ரெஸ்ஸை ரிலீவ் பண்ணிப்போம்.
சார் லைக் நான் வந்து கோயம்புத்தூர்லேருந்து வரேன் சார். நீங்கள் லக்ஷ்மி இன்ஜினியரிங் ஒர்க் பண்ணியிருக்கீங்கன்னு நான் கேள்விப்பட்டேன் சார். அந்த பாஸ்ட் எக்ஸ்பீரியன்சஸ் வந்து உங்களுக்கு இதில் எப்படி ஹெல்ப் பண்ணுச்சு சார்?
லக்ஷ்மி மெஷின் ஒர்க்ஸில் ஒர்க் பண்ணேன், கரெக்டாக. அதில் வந்து நான் ஓகே அந்த எக்ஸ்பீரியன்ஸ் எவ்ரி ஆப்பர்ச்சுனிட்டி இஸ் அன் எக்ஸ்பீரியன்ஸ் ஒன்லி. பட் ஸ்ட்ரெயிட்டாகவே அது எனக்கு யூஸ் ஆகலை. பட் ஹெச்ஏஎல் வந்து கொஞ்சம் யூஸ் ஆச்சு. ஏன்னா அங்கே வந்து நான் இந்த டிசைன்லாம் ஒர்க் பண்ணிகிட்டு இருந்தேன், கேட் மாடலிங், அப்புறம் அனலைசஸ்ஸு, சிஇ அதெல்லாம் யூஸ் பண்ணேன். அது கொஞ்சம் யூஸ் ஆச்சுங்க. பட் ஸ்ட்ரெயிட்டாகவே எனக்கு ரிலேட் பண்ண முடியல. பட் அது ஒரு டிஃப்ரெண்ட் டைப் ஆஃப் எக்ஸ்போஷர்.
தேங்க்யூ சார்.
Hello sir, this is Satyabrat, Instrumentation Control Engineering second year. First of all, congratulations for the success in this grand mission. My question is regarding ISRO's role in like nurturing and development of the space technology and space startup ecosystem in India. Generally, it's very evident that space technology is a very capital-intensive area, which for which many startup people who are interested in going into this startup would be hesitant to go it because of the capital requirements. And how is ISRO treating this problem and help to nurturing them financially in every possible way so that this area keeps on growing and helps ISRO in future in different missions?
You are asking whether our as you said correctly, the space is a risky business and the capital investment is quite large. But you are asking whether this capital investment is okay, is it adequate, you are asking? Or
no,
what?
so I'm asking how is ISRO helping to keep their motivation up in this high risk business?
No, you can see our track record. Like for example, LVM-3, you take it a launch vehicle or a satellite, our success rate is very high. See, PSLV, so many launches took place, only 2 failures are there. Similar way, LVM-3, all are success. Satellites also, you see, one of the question he asked, how much of success rate we have. We are really successful in this business, but it is risky because there are many unknowns and unknowns. If you see the application also, no, for one simple example I will tell you, because that itself is a subject if we have to talk about. Remote sensing you take, potential fishing zone. There are OceanSat satellites which identifies the potential fishing zone. See, earlier days, without that information, a person who goes and catches the fish, he or she has to spend a lot of time and he may not get that fish also what is required. Now this satellite data is very useful. Go to the correct place and get it. Earlier they used to spend lot of crores. Now you have reduced that. It's an intangible benefit. Similar way, you take a communication satellite, broadcasting. Earlier, the 36,000 kilometer orbit, it is fully crowded. It's fully crowded because all these broadband and all other communications are coming through that satellite. Likewise, natural resource management, crop estimation, and disaster management. There are various applications. GPS, our own Navic systems are there. We can actually get the navigation solutions from our own systems. Like that, so many applications are there. It is giving lot of revenue. So we don't have any problem in the budget. Whenever we ask government also, we get budget, and we are successful in doing this business.
And sir, one more question. Suppose I, as a youth, have to start a startup in the space domain. What could be the source of funding from me? How can I achieve the funding regarding this?
So for that, there is an InSpace. It is recently formed. That InSpace is basically to promote and handhold with ISRO and also policy decisions like what we have to do. So I suggest you you just type in space in the Google, and there are people who are located and they are with us only in ISRO, and they will guide you in a better way rather than me telling. So it's not possible to answer now, but they will guide you properly. If you are having an interest, they will guide you properly. You can take up, and all the provisions they will give. Please contact. If you are not getting the correct answer, you take down my number, you call me, I will put it into the correct people.
Thank you, sir.
Yeah. Yes, sir. Sir, please, sir. நீங்கள் கொஸ்டின் கேட்டிங்கன்னா என்னால் ஆன்சர் பண்ண முடியாது. சார், நீங்கள் 2 பேரும் இருக்கிறத நான் மறந்துட்டேன் சார்.
சார்
சார் ஒரு செகண்ட் சார் கொஸ்டின் கேட்குறேன் சார், ப்ளீஸ். Yes, sir.
Each activity is related with the uncertainty almost, right? Yes. The uncertainty and the risk are related. Usually, if an activity is related with more risk, then you may allot more time for that, or different time estimate you will do. As well as cost also different.
Yes, sir.
Is any other metric which you are you using to measure the risk of activity other than time or cost or something like?
Sir, other than time and cost, no sir, no other thing. Only time and cost only we are basically treating as a risk, sir. As you told, it's like a PERT only, sir, whatever we learned, because every activity is unique, sir. It has attached with some risk. We do a risk analysis also, and none of the activity goes correctly, sir.
And one more thing also, sir. For example, just you were talking about PERT and all, like there are some advanced techniques are available, like GAN and all, generalized activity network modeling and all, like where even there are 3-4 alternatives you
use it.
3-4 alternatives you generate. Whichever alternative is succeeding, you will go over that same line. So, are you applying such advanced techniques and all like that?
For Chandrayan 3, I have not applied anything like that, sir. Only PERT only I used to apply. And in fact, sometimes work breakdown structure, simple work breakdown structure also I used to apply. Because this, as you told, sir, we have to do that. We have to improve in this area a lot. In fact, all our ERP, supply chain management, this needs to be used, sir. Our aim was technically to prove. Even the time and cost also was okay. But for your information, sir, 250 crores was allotted budget. We were well within that, sir. Cost wise, we have not exceeded. The very reason was, sir, Chandrayan 2, whatever new developments required, we have developed the infrastructure, sir. No infrastructure development was called for in Chandrayan 3. Only the manpower cost. And our engineers know, sir, as you know, there is no accountability. We work not 8 hours, sir. It's like we are on only all the time. Only outsiders, when we hire, that cost will be slightly more, but we estimated more for that. So that way we have not exceeded. But time is, as you told, time is always there. Actually, we were ready January 2023 itself launch. Because of OneWeb commitments and all, we could not launch. But there are always a time risk is involved, sir. This is what I have seen, sir. I will take your input, sir. Maybe next project I will try to put. I'll talk to you, sir.
Hello, sir.
Yes.
I'm Kanaga, final year triple, sir. So you've said that there are various sensors which are employed in the manual, like the radar and RF sensors. But despite that, only the altitude of the particular satellite will be known to the scientists which are present in the center here in Bangalore. Yeah? So is there a way to change this and get to know about the other coordinates also, apart from the altitude, now that there are many missions which are already there?
No, if I understand your question correctly, you are asking in Bangalore we have developed this instrument and it's only altitude information. Is there other coordinates you want to understand? See, altimeter was developed by Bangalore, our one of the unit. Another unit is in SAC, Ahmedabad, that is Ahmedabad. RF based altimeter was developed by, it is Ka-band frequency range. It was developed by SAC Ahmedabad. Then laser based altimeter was developed by Bangalore, one of the unit. In addition to that, we have velocity sensor that gives another 3 directions, that is x dot y or Vx, Vy and Vz. see the spacecraft is traveling with such a speed, and there is a stationary target. Through Doppler frequency shift, we have one Doppler velocimeter that is also works in laser based principle. So that also we newly developed. It's a state of the art instrument. Chandrayaan 2 we did not have. Chandrayaan 3 was newly developed and it has flown. Then for a redundancy for that, we have camera. That camera's job is, it will take a successive image. For example, a moving target is there. You take one image, within 1000 millisecond, you take another image. There is a pixel offset, and there is a movable target. Divided by distance you put, I mean divided by time you put, you will get a velocity. So it's an indirect way of deriving the horizontal velocity, but it will not give vertical velocity, because we have in the 3-dimensional plane, there are 2 in-plane velocity and 1 out-of-plane velocity. Out-of-plane velocity, we did not have redundancy in Chandrayaan 3. In-plane velocity, camera was there, and laser Doppler velocity, all the 3 velocity information was coming. So all these sensors, 4 sensors were there to give altitude information, that is y, and x dot, y dot and z dot. X and z we did not have any sensor. We had a sensor, but we didn't put in closed loop. 4 information we got.
All right, okay, sir. So with all this information, I mean, based on further improvements, is it possible that we can develop a 2-line element for satellites, lunar 2-line element?
No, a 2-line element is not possible. See, we require all the 6 state vectors.
Yes.
Because for us, we are just working in a 3-dimensional plane. Yeah. We have to have a landing, no? So for which all the information is required. See, if I have to reduce that, even the 300 meters, which I was telling off by 300 meters, we had one camera to give that x and z position also. But we didn't utilize the latitude and longitude. We didn't utilize because we don't want to unnecessarily put in closed loop. We know that the inertial systems are thoroughly characterized, and the site is 4 kilometers. Such a big area is there. We are okay with that. That's why we didn't put. So 6 state vectors are required, and it will be required in future also. All other space agencies is also using this.
Okay, sir. So on further improvements, on further developments with this mission and further missions in future, is it possible that India will be the first country to develop a lunar 2-line element, database for it?
See, it is not for competition with anybody. We have our own roadmap. In fact, ours is basically an application oriented. Space also should be available for the common man. That was our goal. In fact, Dr. Vikram Sarabhai onwards, if you see, the visionary is like that. This is also required because we have to see that futuristic thing also. And a similar way, we have a program for lunar also. There are many missions, very, very ambitious missions are coming up. But at the same time, we are now having the technology. We have to utilize this technology and go to the next step. That's our aim. And given an option, this mission itself, we can do many more improvisation. We have to do that. If you see right now, Chandrayaan 3 is on par with the Artemis mission. Like you forget about 1960s where people have landed, 1967 and all. That systems and this systems, it is a world of difference. We have used all the state-of-art technologies. Luna 25, even though Luna previous missions did not have laser-based principal sensors, whereas the Luna 25 has got, but unfortunately they could not demonstrate. But we have the cutting-edge technology. That's how our aim is: reduce the mass, reduce the power, reduce the size, reduce the data rate. All basically it should be slimmer. It should be less power consumption. It should be miniaturized. That should be our goal.
Thank you, sir.
Good afternoon, sir. I'm Jyotika from 4th year Mechanical Engineering. Thank you so much for coming to our campus back and giving this wonderful seminar, sir. So my question is, as NIT is famous for many student-run clubs, one such is our Third Dimension Aero Modeling Club, where we are a group of aviation enthusiasts who work on design and fabrication of gliders, drones, and recently we have also started rocketry and student satellites, sir. So what would be your suggestion for such students who do not have like professional educators to teach us, but we as students are working on various projects and participating in many competitions?
See, I will only give a guidance. Actually, you have a lot of lateral thinking. I should not be biasing your thing, because you will be you will have more innovation than me. So what I would say is, for you to progress, you should select some people. and that people should be having different expertise. For example, one person may have an interest working in the inertial sensors, some person may be working on the onboard computer, and some person may be working in the power systems. Like that, you select the people who have lot of zeal in working in that area. Then one system engineer should be there. That system engineer should see only with respect to the objective. You set one objective, what for you want to develop this satellite. That should drive your instrument. That instrument, based on that, requirements will be there, specifications will come, you design the system. Every system person, subsystem person, you ask him to come with a lot of options. It should be very innovative. A system engineer should do a trade-off and select weighing various parameters, and everyone should listen to that systems person. If you have that setup, you will make a progress. This much only I can give advice, but it should be having a full innovation. You should be applying new techniques. You are in this era, you should have a new techniques, so that whatever I told, the mass, power, volume, all should be very less, and cost also should be very less, and it should have the reliability also. Finally, you cannot compromise the reliability. All such things you have to do. You only have to work on it. You should not seek anybody's advice.
Thank you, sir.
Thank you, sir. That was undeniably an education session. We are sure that you have given our audience something to ponder about as they leave the lecture. Sadly, all good things must come to an end. We now invite the chairperson of Pragyan, Vijay, to deliver the vote of thanks.
Good morning, everyone. I'm Vijay, the chairperson of Pragyan. On behalf of Pragyan, the student community, and NIT, I would like to thank who have joined us today, Dr. P Veeramuthuvel, an alumnus of NIT, where he pursued his master's in technology, for enlightening us with his invaluable experience. Dr. G. Aguilar, our beloved director, for having guided us throughout with their wisdom and vision. Dean Students Welfare, Dr. Rod Karvembu, and Dr. J. Justin, who guided us throughout this event. I would also like to thank our HODs, faculty in charge, staff, deans, and SAS officers, and the members of the press who have joined us today. I would thank HOD CSG and the CSG department for enabling us to live stream the event. I thank the security officer, his team, and the estate office that has supported us throughout. Lastly, I thank the members of the audience for attending this event. I'm sure each of you have had a memorable experience. Thank you.
And with that, we come to an end of this program. We hope you enjoyed it and found it as informative as we did. Thank you for joining us today.